Welcome to Mixed Model Arts. So I'm going to discuss with you the convergence of data modeling across applications, analytics, and machine learning and AI. So some motivations for this talk. Last year, I traveled the planet talking about data modeling. It's an interesting topic. It's not a new one. Data modeling has been around for many, many decades. But it feels like, in my experience, having been in the field for, quite a while, it definitely, I've seen data modeling practiced rigorously, and I've seen it sort of forgotten about. It's become a bit of a lost art. And so the intention behind the talk last year, which was Data Modeling is Dead, Long Live Data Modeling, was to maybe talk about why data modeling is important and why we need to give it a second look in most cases. Get into reasons why we sort of implicitly data model no matter what, but the explicit data modeling, I see practicing data modeling as a craft, that largely has been forgotten. But what I realized in this talk around the world is data modeling is very much still, I think, very appreciated by people. Got a lot of compliments and so forth for bringing the subject back into the forefront of our industry. So this talk is really a follow-up to this prior talk here, and it's sort of about the next evolution of where I think data modeling needs to go. So did data get magically fixed in this time? No, absolutely not. I still think there's a lot of hurdles to be overcome. But let's talk about some of the motivations, as to why this talk was brought about in the first place, right? As you can see here, the rise of AI means data is getting a fresh look. Data is overwhelmingly a mess in most companies. And the big thing is, if we're going to take seriously these initiatives to embed artificial intelligence and machine learning into every aspect of our business, we need to invest the time into making sure we have a solid foundation for data, right? If we're not going to do it now, then when are we going to do it? So again, did data get magically fixed in this kind of hype cycle of everybody wanted to do ChatGPT and LLMs last year? I think now is the year we're sort of proving this out, and from what I can tell, the crux of the entire matter is data, right? We're talking unstructured data, structured data, and so forth. So let's look at what data modeling used to be in the past, right? I'm an old fight fan. I grew up in the 1980s, so you're gonna have to apologize. My references seem a bit old, but when I was growing up in the 1980s, I think my friends and I would always have questions of would somebody doing kung fu beat Mike Tyson? Would Bruce Lee beat Mike Tyson? Would Hulk Hogan, who we thought was all real back then, how would he do in a fight against all these other people, right? And so, but back then, it was all about like one true fighting style to rule them all, this definitely manifests itself. If you kind of look at where data modeling is, right? I would say there's a lot of parallels to this. There's one true data modeling style to rule them all. I can point to several. Maybe people are in the dimensional modeling camp. If you're in analytics, maybe you're data vault. Maybe in software it's the relational model and so forth, right? And so I think everyone has their sort of data modeling practice that they definitely hold on to, and they think it's better than everything else out there. But I'm going to argue I think this thinking is the equivalent of I think having your favorite pro wrestler or boxer or a kung fu artist and thinking that they can take on any other style and win. The future is very much, I think where we're at right now as an industry is very similar to what happened with mixed martial arts, where in the early 1990s, the UFC really popularized this notion of getting people from different styles and having them, get into a cage and see who comes out on top, right? And so what happened over time, whereas I think the recognition that being one-dimensional in your fighting style probably wasn't a good idea, and so what you started seeing over the decades was a fusion of say Brazilian Jiu-Jitsu with Thai boxing and Western boxing, wrestling, and a multitude of other styles, to the point where today, if you were to get into mixed martial arts, it would serve you no purpose to be good at one particular style. You need to know a lot of things, and so this the parallels to data modeling is that the world is becoming a very heterogeneous, multimodal environment of use cases, of different types of data, and increasingly the roles of maybe applications, analytics, and machine learning. All these roles are converging. A few years ago, the discussion was really, let's focus on a particular use case. But I think the recent attention on AI has blown this completely out of the water. Software engineers now looking at embedding AI use cases into their workflows, and there's not an analyst I know who isn't trying to figure out how they can incorporate large language models into their work, and both internally and externally, right? And then you have other use cases like embedded analytics, which has been around for a long time. You have data-powered applications, AI-powered applications, which are becoming more and more a common way to build applications, and finally, it's I think the notion that across a spectrum, when we're dealing with things, especially when we're talking about streaming systems, the feedback loop between application, analytics, and machine learning is just becoming a lot tighter and a lot shorter. And so gone are the days when you'd need to be maybe one-dimensional. I believe that the future is about a convergence of skills. The person who uses data will need to be cognizant of the modeling techniques and how to handle data both upstream and downstream of them, no matter where in the life cycle of use cases or types of data you're working with. The days of working with just tables, I think it's gone. There's you're going to be expected to be able to work with not just tabular data, but semi-structured data, unstructured data, probably all within the same modeling scheme. So that's really the essence of what when we talk about mixed model arts. So what's a data model? You might have your own idea of what a data model is. And I'd like you to maybe reflect on that for a minute. Like, what do you consider to be a data model? And I would also urge you to reflect, like, what is not a data model, right? So when we talk about the notion of a model, I think it encompasses a lot of things. There's obviously the hierarchy of conceptual modeling, which is where you want kind of describe how entities and attributes relate to each other. Trying to describe that within the context of a business vocabulary, the information workflows, the business rules, and basically just understanding how your business works, right? And trying to model that with data. And so you implicitly do this, right? I was talking about this earlier. You do this whether you understand it or not. I think most people will jump straight to either logical modeling, which is sort of translating the conceptual model, whether that's written down or whether that's in your head. That's basically the logical model is sort of the intermediate step where you're translating that conceptual model into the physical model. And this is where I think most people end up modeling these days, is they figure, let's focus on the physical system we're going to be throwing data into. That might be a columnar database. It might be an open table format like Iceberg or Hudi. It might be any number of things, but I think people so often focus on the physical components of modeling, they miss the bigger picture in terms of what they're trying to translate from the data model conceptually into a logical model, and finally the physical. This should be the order of operations, but we seem to get it backwards, and then we just throw data into the physical systems first. And I would urge you to maybe take a step back and think about what you're doing before you do that. So anyway, those are maybe the hierarchies of what a data model is. But let's, this definition of a data model comes from my upcoming book on data modeling. And my definition is a data model organizes and standardizes data in a precise structured representation to enable and guide human and machine behavior, inform decision-making, and facilitate actions. So notice that this definition doesn't encompass things related to physical modeling, right? It's not about an approach where I'm either going to do dimensional modeling or some other approach, right? I think this is meant to be very agnostic to any approach and also any type of data in any use case. I'm also recognizing that the world is increasingly incorporating machine learning and AI into its workflows. And to sort of hedge where things are going. I think increasingly going to see machines taking over quite a few tasks that traditionally were even more done programmatically as data scales. I think that especially when we're talking about unstructured data, like pictures and audio and text and so forth, that's just the reality of where data is going to be baked in alongside the traditional use cases, especially for machine readable data, which has typically been writing code for applications and so forth. So again, this model is, I think, it does represent a step forward where traditionally we've been talking about data modeling in the context of serving business and IT and related type things. This I think represents the direction that we're heading in the world, where it's people and machines collaborating together. And we need a way to model data for this. So that's the definition. So I think it's worth noting what went wrong in the industry. There were, I think, a few things. Data modeling sort of fell by the wayside, I think, for a couple key reasons. It became very much one-dimensional, as I pointed out. People were fixated on their technique, I think often at the expense of other techniques. Also, it was, I think, very... The approaches didn't keep up with where technology and practices were going, right? So I think that the last evolution of a major data modeling technique was the data vault, right? And I think that was published around 2000-ish. Before that, you had 1996, where Ralph Kimball introduced dimensional modeling, and prior to that, you have Bill Inman, who introduced the notion of the data warehouse. And again, this is for analytics, but the way we use data, the way we store, query, and retrieve data and so forth, a lot of that has changed over the years, especially since 2000. You have NoSQL, you have big data, you have the internet, and the rise of just massive amounts of data. What happened since 2000? You have AI and ML, streaming, and all these other things, right? And these are all practices and use cases that don't quite neatly fit into the data modeling techniques I described. And so a lot happened, but no, I feel like the thinking of the industry sort of didn't keep up. And so people were still, I think, trying to shoehorn in these traditional data modeling techniques, which are awesome approaches for what they're intended to be used for. But there weren't a lot of new innovations from a modeling perspective. And meanwhile, obviously, the technologies made it much easier to work with data. But I would say that the crux really came, and what went wrong here is that it became easy to work with data, but that's not the same thing as intentionally using data to model and solve problems for the business. And so what often happens is people will basically just throw data into a data lakehouse, a data warehouse, or whatever, and without much rhyme or reason to it. Right, I see this very often. Even with the newest data lakehouse architectures and open table formats, you have the ability to do a lot of amazing technical things, time travel partitioning and so forth, which is amazing, and in fact, it's all open source, truly awesome. But the same underlying problem occurs, where if you're not thinking about the data and how you're going to model it, what it represents, you're still going to be stuck. And this is the same thing I see often, where I see a lot of data being stored. I don't see a lot of utility from the data that's being stored. And what happens over time is it develops a ton of technical data and organizational debt that the people responsible for handling the data need to figure out a way to pay down at some point. And so this is, I think, among a few other reasons that that went wrong in the industry with data modeling. But for the purposes of brevity, I'll leave it at that for now. And what's happening? There's, I would say, a few trends happening right now. Obviously, with AI, sort of again bringing the discussions of both AI, obviously, and then data to the forefront. We're revisiting a lot of discussions on data. I think people are taking a second look at the practices and maybe how they're using data, how they're thinking about it, how they're cataloging it, how they're storing it, and so forth. And then finally, how they're modeling it. The discussion, again, from the earlier slide, when we're talking about traveling the world, talking about data modeling, it felt like a breath of fresh air for a lot of people to hear that data modeling hasn't been forgotten about, hasn't been thrown to the wayside. And when you talk to people who are working with data, this is sort of what it feels like. I can joke that these are probably two 25-year-old data engineers. This is their the data sets they work with, and that's an absolute horror show, right? It's nothing I would say that you would want to be proud of, but the thing is, people get so used to it. Like these people here, I'm guessing they probably don't even realize where they live. They're just kind of used to it, and this is the problem with a lot of people's data sets these days, and the data models or lack thereof, is we just live in the sea of incomprehensible junk, right? So data modeling is how we bring organization and structured representation to data to make it useful, again, for actions, for decisions and so forth. But we have to get our house in order. So the future, let's talk about that. I believe the future is mixed model arts. And what does this mean? Well, it's kind of what we described before. It's the fusion of various data modeling approaches up and down the spectrum. You're going to need to know how to model data at the application level, usually where data is created. Please be cognizant of these methods, right? If you're working with a relational database, understand the relational data model. It's crazy how many times I see relational databases that don't have relationally modeled data. The relational data model is, I think, a work of art. It's been around since 1970. And the underlying concepts are just pure set theory and first order predicate logic. I would urge you to understand the relational model, because if you work with tabular data, all other data models flow from the relational model. It doesn't work the other way around. And so if you understand the relational model, it sets you up to understand in analytics, the dimensional model, data vault, one big table, and so forth. But you have to understand how normalization works to understand how to denormalize. But all too often we start from a denormalized perspective and call that good. But if you understand how relational modeling works, you understand how to avoid side effects, unnecessary dependencies of your data, and so forth, right? That's just one aspect. That's dealing with tabular data. Now you need to know how to work with semi-structured data. You need to understand, okay, so I'm going to translate entities from a relational model into entities that might be in JSON or similar in nested data. What does that look like? How do I manage relationships? Maybe a one-to-one, one-to-many, right? Maybe I could use a Reis, something like that. But you need to understand how you translate these various approaches. And in analytics, same thing. Denormalization, what I just talked about. Machine learning. How do I work with unstructured data sets, images, text, video? How do I bring all this together, right? What's the metadata that's going to allow me to identify all these different attributes and entities across the different types of data I have, and tie them together, right? These are the things you need to start thinking about. It isn't just a one-dimensional world of tables. There's a lot more. Then when you introduce streaming into this, now you have a time component where there's velocity involved. And so how do you blend all these together? This is the essence of mixed model arts. This used to be, I think, the path that people would think about data and how it flows. It would start from the application, and go to analytics, and finally to machine learning and AI. But the crux of this is that this assumes that these are all prerequisite steps to one another, right? Where you have to get the application, the analytics, the machine learning all in that order. I often hear people say that you can't do machine learning or AI until you get your analytics under wraps. And so I think that it feels like a very gatekeeping argument, where I am seeing companies that are just jumping straight into machine learning and AI using unstructured data sets. Does that have anything to do with analytics? Absolutely not. And so this is the future, where you're going to see a convergence between applications, analytics, machine learning, and AI, where all these different data models used in each use case, they feed upon each other, and they're used within each other. So the feedback loop is multi-directional and multimodal data. And this requires, again, that you understand all the different ways of modeling data across different use cases. This is the heart of mixed model arts. There's another thing I want to talk about real quick. Andrew Ng is the proponent of data-centric AI. And what this means is, in order to do AI successfully, it's not just about algorithms, it's not just about hardware. It's certainly important, but at the heart of having great machine learning, great AI models, is the data itself. It's all about having data that can be used by these models to represent what it is you're trying to represent. And this comes down to having great data models, great data sets, and so forth. So be conscious of the data you're using. And I hope that the practice of thinking more clearly about data models, again, from a conceptual, logical, and physical level, will guide you towards a future where we can really get the most value out of our data, whether it's in AI, analytics, and so forth. But Andrew's idea of data-centric AI, I think, really hits home for me, and hopefully it does for you too. This is actually from a discussion we had a few weeks ago on my podcast, where we're talking about how data engineering, facilitates data-centric AI, and so this is something I believe in. I know Andrew does as well, and you can see this as evidence when in machine learning, when you train models, they're either going to be useful or not, depending on the data you provide them. So just keep that in mind. So closing out, I would like to at least leave you with this quote here from Bruce Lee, which is I think a very it sums up mixed model arts and also mixed martial arts, which I attribute to Bruce Lee through his work with Jeet Kune Do back in the day, which is a fusion of different styles of martial arts. I think he was very much ahead of his time. But his quote's this: absorb what is useful, reject what's useless, and add what is specifically your own. So I think as long as you understand all the different use cases, all the different modeling techniques, you understand what's applicable to you. And that's the most important thing. But you need to know what technique works where, what approach works where, what approach wouldn't work where, when you can break the rules, when you can't. But until you know all the different techniques, all the different approaches, all the different use cases, it's going to be very hard, I think, to be as proficient in working with data as you possibly can be. So again, absorb what's useful, reject what's useless, and add what's specifically your own. Thank you.